Hi guys, in this video we're going to have a look at the process of iteration. So iteration just means you repeat a process until you get to a desired goal or target. So in this particular case what we're going to do is we're going to use iteration to try and find a solution or a route to these equations here. Okay, so usually you get something like this where it's in two parts and they might ask you to rearrange it. And then they'll ask you to use iteration to try and get a solution. So we're going to do both parts and look at a couple of different examples and a few things to watch out for. So let's go with this one. Show that the equation x cubed plus 2x minus 5 equals 0 can be arranged to give this. So the little bit of a clue here is you pick one of the x's. You've got x cubed and you've got x, and basically you rearrange it to make that the subject. So you definitely need to be able to rearrange equations comfortably. Have a look at my rearranging equation video if you're a bit unsure. Now you can pick either one, however we're aiming to get this. Now because there's a cube root, I'm going to hazard a guess that they've started with this one. So I'm going to pick the x cubed and then I'm going to rearrange it to get x on its own. So that's what I'm going to do over here. So I've got my x cubed plus 2x minus 5 equals 0. Like I said, that's the x I'm going to pick. So I'm going to rearrange or change everything or rearrange everything else to make that x the subject. In which case I'm going to take away 5 to start off. Sorry, plus 5. Remember, always do the opposite. To both sides first, so that's going to leave me with x cubed plus 2x equals 5. Now I'm going to get rid of this plus 2x by doing the opposite and minusing 2x to both sides. That's going to leave me with x cubed equals 5 minus 2x, which is looking good. Now to do the opposite of cubing, I'm going to cube root both sides. So x equals the cube root of 5 minus 2x, in which case I've proved it. Excellent, 4 marks, happy days. If you can't rearrange it in the exam, doesn't matter as much. I mean, it's not the end of the world because they give you what it is, and that's what you're going to use down here when using the iterative process or using iteration to help you find the solution. So like I said, you keep repeating the process. And it tells you what to start off with. It says your starting point, so when x is 0, okay, you put in 1. So this is what I'm going to write down now. So x 0 equals 1. So that's your starting point, and that's what you put in here. Now don't be put off by the xn plus 1 and the xn, because all that means is xn, well, I start with x equals 0. This is my starting point. So that just means when x is 0, I'm going to put 1 into here. I'm just going to substitute 1 into here. And of course, this n plus 1 just means that when I put n0 into here, so x0 plus 1, that'll give me x equals 1, which is what I want to work out, x1. And when I put x1 into there, I need to add 1 to it to get x2, and so on, and so on, and so on. So let's have a look and solve that. So this is definitely a calculator job, so you need to be able to do your cube root. In my case on this calculator it's shift and I press the square root button. Notice it says cube root there. Then I'm going to stick in 5 minus and then 2. Now it's times xn. Remember what I said, x0 is your starting point, so I times that by 1. So this is going to give me my next solution, which is 1.4422495 7. Now, it says correct to 3 significant figures. So over here, I'm just going to put 3 significant figures and write down what the 3 significant figures are. In which case, the third significant figure, well, there's 1, 2, 3, and 2 tells you to round down, so it's 1.44. So this number here, rounded to 3 significant figures, is 1.44. Now, that's not your answer. Like I said, iteration, you keep doing the same process until you get to a desired goal. So what I'm going to do is find out what x2 is. And the reason how I do that is I substitute this answer back into here and find out the new answer. Now this is why these calculators are cool, because what you can do is keeping that number there, don't clear it, keep it there, and if you type it in again, the cube root and then it's 5, take away 2. Now this is where you'll be a bit different. Don't type that in. What you can do is press times and then your ANS, your answer. So what that does is it substitutes your previous answer on the calculator into this new calculation. So all I have to do now is press equals, and it gives me the next answer, which is 1.28372225. And again, I'm going to round that to 3 significant figures, which is 1.28. Okay? And the idea is you keep going until the 3 significant figures is the same. And this is why I said put the previous answer in, because I don't have to type anything in anymore. All I do is I just press equals, and it gives me the next one, because it's already substituted in that previous answer into this calculation, and it spits out 1.3448925544. So the 3 significant figures, that is 1.34. So again, these aren't the same, so I'm going to press equals again to get what the next answer would be, which is 1.32195742. Round that to 3 significant figures, 1.32. So we're getting there. It's getting a bit small, these gaps, but still not repeating. So I'm going to press it again, press equals again. So the 5th one here is 1.3306494464. 3 significant figures is 1.33. So we're getting close. I think maybe one more might have it. Press equals again. 1.32736867 and 1.33. Yep, because the 2, look at the 7, tells you to round it up. So these are now the same. So this looks like our solution. I'm just going to do one more though to double check. 1.3286089007. So again, yeah, the 8 tells you to round up. 1.33. So you see here, to 3 significant figures, we're starting to repeat our answer. So your answer to 3 significant figures would be 1.33. Okay, and that's how you use the iterative process to get a desired goal. So that's one example. Let's have a look at another one. So again, I've got like part A, if you like, where I need to rearrange this to get it to be this. So what they've done here is I've still got my x cubed intact, so clearly I haven't touched that one, so I must rearrange to get that x to be the subject. Now at the minute it's minus 3x. Don't like minuses, so I'm going to make that a positive. That's going to be my first step. So to make this a positive, I'm going to add 3x to both sides. So x cubed plus 1 will equal 3x. Now remember, I wanted to make that x the subject. If you look over here, look, x cubed plus 1, x cubed plus 1. So I'm nearly there. So all I'm going to do now is divide by 3 to both sides to get rid of that 3. Which will give me x cubed plus 1 all divided by 3, which equals x. Doesn't quite look the same, but if you remember, if you divide by 3, that is the same as timesing by a third. So actually they are exactly the same thing. Just make sure you do put it into brackets though, to show that you're timesing everything by a third, which is the same as dividing everything by 3. So there you go, that's an example of rearranging it when it's not that x, you're rearranging it when it's that x. So again, we're going to use the iterative process. I've got my starting point here, so x0 equals 0.5, and I want to know what the next answer is. So back to our calculator. So I'm going to use the fraction button and say 1/3. Then I've got my open my bracket, and again, the xn is just the first number you put in here, which is 0.5, and we cubed that one, so cubed, and yeah, as I thought, so make sure you press the arrow, make sure you're not adding 1 to the cube, make sure you're just adding 1 normally, closing the bracket, and press equals. It gives it as a fraction, but I want it as a decimal, which is 0.375. What are we rounding it to? What are we after? This time we're not after significant figures, we're after 2 decimal places. So we'll put a little note here, 2 decimal places, or 2 dp, and round this to 2 decimal places, which is 0.3. Oh, sorry, I put 0.38. So let's find out what the next answer is. So again, typing it into your calculator. So my third, then I've got my bracket. Now remember, we use our A and S button to use the previous answer, but I've just realised I think I've cancelled it, so I just need to type it in again. So if you do that, and you do cancel it by accident, just type it in exactly the same to get the previous answer. Oops, like so. So keep that on your calculator, then you can just type it in again using your answer button as opposed to the X. So I'll use the previous answer, then I can plus my 1 and then close the brackets, and that gives me, press the SD button, that gives me 0.3509114583. So round that to 2 decimal places, 0.35. Now of course they're different, so I need to keep going. So I'm going to press, because I've used the answer, I can just press equals again to give me my next answer, 0.3477369447. So to 2 decimal places, that would be 0.35. They're the same. Let's just do one more. Press equals again, 0.3473495644, and again, running that to 2 decimal places, 0.35. Excellent, they're all the same. So your answer would be 0.35. So that's just another example of the iterative process. Got one more for you to have a look at, which is this one here. So this one hasn't given us part A or part B, but we're expected to be able to sort that out ourselves. It says the equation x cubed minus 2x squared plus 19 equals 0, and it has a solution, or a root if you like, between minus 3 and minus 2. Use the iteration to find an approximation for the root, and again we're rounding this one to 2 decimal places. So, first thing we need to do is rearrange this to give us our iterative formula. So pick an x, I'm going to pick the x cubed, and let's start rearranging. So I'm going to rearrange to get change this x, rearrange to make this x the subject. So I'm going to plus 2x squared to both sides. I'm going to get rid of that 19 by doing the opposite and taking away 19. And the last step is to cube root both sides to get rid of that cubed. So x equals the cube root of 2x squared minus 19. And again, just as you saw in the previous ones, this x would be your x plus 1, and then it will be the cube root of 2x, and that's your n, because that's your starting point, squared minus 19. So this is what I'm going to use to now help me find out a solution to 2 decimal places to this equation. Now it says your solution is between minus 3 and minus 2. Now you can use either one of these as your starting point. It doesn't matter, either one will get you the same answer. I'm going to pick minus 2 just because it's the smallest one, but you can use either one. So my first answer there would be minus 2. So let's have a look at the other one, and again we're running to 2 decimal places each time. So, I need this, don't I? So let's plug it into our calculator. I've got the cube root of 2 times the first answer. Now I'm going to put this in brackets because I'm timesing it by 2 and I'm squaring it. So it's minus 2, close bracket, squared, take away 19. So I just put the minus 2 in brackets here. because I'm times it by 2 and squaring it, so the calculator doesn't get confuzzled. So if I press equals, I get minus 2.2239. I'm not going to write all of it out this time. I'm just going to round that to 2 decimal places, which is minus 2.2. Now let's type it in again, but use our answer button. So keeping that on the screen, I cube root 2 times, and again I'm going to put the answer this time in brackets, because I'm times it by 2 and squaring, then minus 19. So press equals, and the next one will be minus 2.0883. Now again, I'm not going to finish writing it all out, because I'm just going to round that to 2 decimal places, which is minus 2.09. So again, miles off. So press equals again. Get the next one, minus 2.1741. Again, I'm not going to write it all out. Minus 2.17 to 2 decimal places. So we've got a little way to go yet. Let's press equals again. Minus 2.12131 to 2 decimal places. Minus 2.12. Need to keep going. Big one, this one. So minus 2.15443. Again, I'm not going to write it out anymore. Round that to 2 decimal places. Minus 2.15. We're starting to get a bit closer, which is good, but still not quite there. So the next one is minus 2.1339. Again, blah, blah, blah. But I'm just going to round this to 2 decimal places, which is minus 2.13. Still not quite there. Seventh one, minus 2.1467 to 2 decimal places is minus 2.15. This is getting more promising, but still not 100% there. So one more, minus 2.13875, again to 2 decimal places, minus 2.14, because that 8 rounds that 3 up to a 4. So getting very close now. Let's go one more, see what happens. Minus 2.1437, so minus 2.14 to 2 decimal places. This is getting very good. Let's do one more, double check. Minus 2.14062 to 2 decimal places, minus 2.14. There we go. 2 decimal places, minus 2.14. So obviously it's in between the minus 3 and the minus 2. And 2 decimal places, that's the solution that we're going to get. So remember guys, use your answer button on your calculator to help you speed things up. And that's how you do iteration. Hopefully that helps. Thanks for watching.